In this video, we will spend a few minutes showing you how to use CCQ to create elastic HPC jobs with the Slurm scheduler. With this video, we've already created the control instance and also the HPC environment, so we'll be proceeding from there. To access the web SSH term, go under Overview. Now select the Login node and choose Terminal. Now enter your username and password, and if you've set up multi-factor authentication, you'll enter the token there, or you can choose the private key. Now you're into the SSH term. Now to test out this CloudyCluster instance, we're going to go ahead and copy the sample jobs from /samples jobs in the software directory. And then we'll go ahead and change directory into there. Now I'll go ahead and compile the software with the MPI prime compile.sh. That actually just compiles the binary on the shared file system. Now you can see it's compiled. I'll go ahead and take a look at the MPI prime.sh file. And you can see we both have PBS and SBatch commands. I'll comment out the SBatch commands, so we'll have 2 nodes, 2 CPUs per node. The MPI run has the 4 processes that will be run. And then we'll go ahead and have that ready for testing. With CloudyCluster, we also have the ability to use preemptible instance types. And with that, you can see we've added the CC directive, GCP UP, and then we'll have 4 instances and 2 tasks per node. Now here I've created 5 different MPI prime jobs, and you can see that there's a 4-4 and an 8-8 and a compile and a preemptible. So each one of those is run separately. The compile has already been run to set up the binary, and then 4-4 is 4 cores, 4 instances, 8 cores, 8 instances, and preemptible uses preemptible instances, and the standard prime is 2-2. To submit a job to the metascheduler, we will use the CCQ sub command. And we will launch the 4-4 job. And now we'll take a look at that job, and you'll see that we have the hashtag CC GCPIT, and that's where we're setting to a C2 standard instance type. This is an optional parameter, but if you want to force things to a certain instance type, like a C2 standard, that will allow you to take advantage of the placement policies that automatically happen under the covers with CloudyCluster. You'll also see that there are both PBS and SBatch commands in here. We've designed CloudyCluster that you can actually build jobs that will work in multiple environments, multiple schedulers, just like you can with traditional HPC jobs. For this job, we have SBatch number of nodes 4 and number of tasks per node 4 also. And that's where we get the 4-4. And you'll see below the MPI run with the 16 total processes for the job. Now we can do a CCQ stat to see the status of the jobs, and you'll see that we've already launched the MPI prime 4-4, and so those are starting to create the compute group, as you can see from the status. Now these status responses are from CCQ at this point, but when the nodes are all spun up and ready for the job, it'll actually hand it off to Slurm to do the actual computation. In a couple of seconds here, you'll see the instances starting to spin up for the first job we submitted. And now we'll go ahead and submit the preemptible job that we talked about. And here's kind of an overview of that. We saw that before when we were looking and editing. Now while those are creating, let's go ahead and look at the instance templates. And you can see on the second one down that one of them has the placement policies of compact. So that puts the instances closer together to get that lower latency, higher MPI performance. And if you use the C2 instance types or the supported instance types for those placement policies, it automatically happens under the covers. Now to speed along this demo, we'll go ahead and launch another job, and then we'll watch the job status and speed up the video so you can see the jobs create, the instances, as well as tear down when they're done. And as you watch these jobs, you'll notice the various stages they go through, from provisioning to submitted to running to completed. And when they're in the running stage, they're actually handed off to Slurm to do the processing. And then when Slurm is finished, it starts to tear down the nodes when the job is done. And CCQ handles all the provisioning and tearing down. Now, generally using HPC, your jobs will run much longer than the few minutes that these MPI prime jobs do, but these are a good illustration of how longer standard jobs will run. And at the end, you'll see we even have the results with the MPI prime output time, and it does decrease as the number of nodes increase. We appreciate your time. Thank you very much.